You've probably already seen the Spot Puppy Piles entry video, and in that, Spot works fine, but we all know robotics is never that easy.
Legs is pairs.
So in this video I'd like to tell you about what we did wrong building Spot and what you might be able to do to build a walking robot better. In the early versions of development, Spot fell over all the time and couldn't support his own weight, let alone walk. In this video, you can see that the servos are not strong enough to return the legs to their neutral position before starting the next step. This caused the legs to collapse, and as you can see, Spot became very unstable in the corner. In an attempt to reduce the torque on each servo, I tried shortening the limbs from 8 cm to 6 cm per limb piece. That helped a little bit, but Spot would still collapse, as you saw in the first video. In earlier versions of Spot, plastic gear servos were used. Plastic gear servos stripped when subject to strain, which means the little gears inside of them lost their teeth, and the servos became useless. On Spot Puppy 2, I designed hooks on the shin and hip for elastic bands to hook onto. These were designed to reduce the maximum torque that the servos would have to put out. One of the most liked posts on the Spot Puppy Twitter is this video of Spot trying to balance on a piece of wood. In this video, Spot's trying to find the angle of the slope he's standing on and lean up the slope to assist with balance, but as you can see it's very slow and not very useful for much. This is the sensor that Spot was using in that video. It's an accelerometer. Accelerometers measure acceleration, and because gravity is an acceleration, you can quite easily find which way is down by just doing some basic maths. Accelerometers do have quite a big flaw though. If you at all move the accelerometer around, even the tiniest bit, external accelerations come into play and the angle unit is not precise nor accurate. Now you can counter this by averaging the accelerometer over time, but that will really slow down the rate at which the angle can change, and therefore the rate at which Spot can move. In the video you can see Spot is quite slow, and that's because I've had to damp the accelerometer output a lot because it was so noisy. After realising that the accelerometer isn't going to be of much use, at least for the main angle measurement device, we switched to this, an accelerometer and gyro combo. Gyros or gyroscopes are sensors that measure angular velocity. You can add up these angular velocities over time to get a very accurate measurement of what angle the robot is at. However, gyros are subject to something called gyro drift, which basically means even if the gyro is completely flat, over time it will think it's rotating very slowly, which means after about 20 seconds, Spot will just fall over because he thinks he's on a slope when he's actually not. Now you can fix this by slowly mixing in the accelerometer, which is very noisy, into the gyro values, which sort of pulls the rotation towards the correct position. And this is what we did and got a much better result. This is a video of Spot balancing with the accelerometer and gyro. As you can probably see, he's quite a bit faster at reacting to the floor, but he fell over. Well, we're getting there. At this point in the build, I thought the hardest part was over. The robot was built, the legs could be controlled, and Spot was almost ready to walk. Oh, how wrong I was. This is a video of different walking gaits. A gait is the way something walks. Different gaits have different benefits and drawbacks, like speed and stability. The gait I chose for Spot to walk with is the trot gait. I chose this for 3 reasons. It's fast, stable, and it's what Boston Dynamics Spot Mini uses, and I think they know what they're doing. But the big issue with this gait is that it's very sensitive to how the robot is balanced, and when the weight distribution is not perfect, the robot will fall over. A lot. This means that the robot requires a lot of tuning or an active balance system. The purpose of the active balance system is to bring the centre of gravity into a stable position around the centre of the legs so the robot doesn't fall over. When I tried implementing the active balance system into the robot became less stable. I'm pretty sure this is because the servos can't make precise enough or quick enough adjustments to the balance to make the robot stay stable. The one thing that I found helped most with stability on Spot is making the legs at a slight angle and not straight downwards. This feature really helped with Spot stability, and you can see it in most of the videos by the legs tilting outwards slightly and not going straight down. If I were to print Spot again, I'd use a high melting point material, like ABS, instead of the PLA that he's currently made out of. This is because when Spot's in use, the servos get warm and have now melted one of the joints on the servos, causing the leg to fall off. I would also add a small ventilation fan to Spot's back. Although these slots do help, the Pi and Red board get very hot whilst controlling 12 servos, and I think that might be dangerous to the Pi to run at that temperature. Lastly, I'd mould feet out of rubber latex rather than using half squash balls. Squash balls do have a lot of grip, they're quite heavy compared to the rest of the leg, and when the legs are running, the squash balls do definitely slow down the legs a lot. Thanks for watching, and I hope to see more walking robots and Pi wheels next year. It's definitely a challenge, but it's really fun when you get them to work. I will put the code on GitHub soon if you're interested, but I've got to clean it up first. Thanks.